In this video, we're going to look at some word problems. I would really encourage you to pause the video often so you can try to work these problems out on your own and then watch the video for an explanation. Okay, so this first video is first problem is kind of a classic one of just a work problem. So it says a small pump can pump all of the blood out of an average turnip in 30 minutes, and a larger pump can pump all of the blood out of the same turnip in 20 minutes. If both pumps are hooked up to the same turnip, then how long would it take to get all of the blood out? And so we're going to use this idea that they're going to perform one job. Okay, and we're going to calculate the amount of work each, or the amount of blood that's pumped, or amount of work that's done for each pump. And so we're going to use this same idea that you might have seen before as just rate times time. So it'll fit in this total category. So it's rate times time. So when we think of rate, we're going to use the rate as the job per minute in this case, because it's in minutes. So the small pump is what we'll put here, and the small pump has a rate of one job in 30 minutes. And the rate of the larger pump is one job in 20 minutes. And we want to calculate how long it takes for one job. And then time, we don't know. That's what we're looking for. How long will it take? And so time, we're going to put just as t for how long it'll take. And now you have an equation you can solve. One thing is, let's kind of rewrite this in a way that you probably would see it if it were just an equation. You would have t over 30 plus t over 20 is equal to 1. And you can kind of see a shortcut for writing these equations with these types of problems where two things or two people are working together to complete a job. It'd always be equal to 1. The time it takes them together goes on top, and the time it takes each one of them individually goes on bottom. To eliminate these fractions, we can multiply the whole thing by 60 if we want to get rid of the let me grab this color. Get rid of the fractions. So 60 over, or 30 goes into 60 twice, so it's 2t, and then plus 3t is equal to 60. Or 5t is equal to 60, and so t is equal to 12. And so if they work together, it would take them 12 minutes. One thing with this problem is to make sure your answer makes sense in context of the problem. So if one works by itself, it's only going to take it 20 minutes. So if it's having some help, your answer should be less than 20. And so that does make sense. Okay, pause and try the next one if you haven't already. This says a ratio of new reported male AIDS cases to female cases in 2008 was 15:7. So this is a ratio. Okay, so that's going to imply we got to figure out what's on top and what's on bottom. Okay, so ratio, they're comparing male and female. So I'm going to put male on top and female on bottom. And so when I set up my proportion, that's the pattern I'm going to use. So 15:7, and that goes in order, so male over female, so 15 over 7. And then if there were 16,000 more male AIDS cases than female cases, how many reported male cases were there? So let's say there's 16,000 more males. So that would be x plus 16,000 if there were x females. And you might want to make a note with your variable x is the number of female cases. So once again, the key for this equation is to look for the ratio, look for top and bottom. Okay, then you can cross multiply 7x plus, let's see, I need a calculator for that one. 7 times 16,000 is 112,000 when you distribute. And that's equal to 15x. So 112,000 is equal to 8x when you subtract 7, or x is equal to 14,000. But remember to always answer the question. So they're asking for how many reported male cases there were. 14,000 is the number of female cases. So we have to add 16,000 because there were 16,000 more males. So 14,000 and then plus 16,000 is 30,000 male cases. Okay, this next one, a tug can push a barge 144 miles down the Mississippi River in the same time, and I've already underlined that because I read through this already, same time that it takes to push the barge 84 miles in the Gulf of Mexico. So same time, that gives us a setup for equation. Time equals time. Time equals time. And we want to figure out, okay, well, what do we know about time? Well, we know distance is rate times time. And so if I divide both sides by r, then I know distance over rate is equal to time. So that's what we're going to set up for our ratio. Let's call this one the river, the left side, and the right side the Gulf. And so we have distance over time for the river is equal to distance over time for the Gulf. And now we have the bones of our equation, and we need to figure stuff out. Okay, so we have 144 miles down the river, so that's good. That's a distance. And I also know 84 miles in the Gulf, so that's in the distance here. And then, oh, I said time and I meant rate. Oh, I'm sorry about that. Hopefully you caught that mistake. I wrote it over here, distance over rate. I don't think I was looking at time. So distance over rate. Okay, so the rate, it says the tug speed is 5 miles per hour greater going down the river than its speed in the Gulf of Mexico. So 5 miles an hour greater going down the river. So in the Gulf, if my speed was x, then 5 miles an hour greater would be x plus 5. Now that's kind of tough to do. It takes some practice. One thing you can do is just don't think too much about where the variable goes. Just pick a spot. So if you pick for the x to go here, okay, so then that's x. What would it be if the tug was 5 miles an hour greater? The other thing that might be helpful is to look for a pattern by picking numbers. So say the tug speed in the Gulf was 15, then this would be 20. If it was 10, this would be 15. And try to find the pattern and then insert x plus 5. Okay, and then cross multiply and solve, and hopefully you're kind of home free now. But let's go ahead and do this. 84x and plus 84 times 5 is 420. Whoops. 420 is equal to 144x. And then when we subtract 84 from both sides, what would that be? I should be able to do that. 60x. And then divide, and you get 7. When you divide by 60. And so once again, make sure you answer the question. Well, we picked x was the speed in the Gulf greater going down the river than what its speed in the Gulf. So we picked x as 7, and that's the speed in the Gulf we said here. And so it is 7. So speed in Gulf. Let me move this up. Is 7 miles an hour. Okay, let's look at the last one for this video. An aggressive portfolio, the ratio of money invested in stocks to money invested in bonds should be 5 to 1. So we have a ratio and then 5 to 1. So we got to figure out what the ratio is, top and bottom of the ratio. So it's invested in money invested in stocks, and look at this word here too. So it's stocks to bonds. So that's what we're comparing, stocks to bonds. Okay, and then I'm told it's 5 to 1. So 5 is on top, 1's on bottom. And then we have to figure out what Haley's doing here with her aggressive portfolio. She has $20,972 more invested in stocks than bonds. So let's make X the amount in bonds, and then X plus 20,972. And that's where you should pause the video and make sure you make sense of that. Maybe rewatch that, but make sure you can come up with this X and then X plus 2,972. And then cross multiply. So you get X plus 2,972 is equal to 5X. Or when you subtract X from both sides, it's equal to 4X. And so X is equal to $5,243. And let's make sure that that's what they were looking for. We want to, how much does she have in her portfolio? Okay, so that's not the answer, but it is how much she has in bonds. But she's got this much more in her portfolio. So this is kind of tricky. Make sure you add up everything. So she has 5,243, but then plus another 5,243 plus 2,972. And that's her total amount that is invested. And let's see what that is. So that's 31,458. So this one's tough. It's tough to set up. It's also, tough to find this value, but then also make sure you answer the question, how much does she have in her portfolio total? So it's the total amount in the bonds plus this total amount in the stocks. Okay, good luck with word problems. They are tricky. Watch this video again. Think about these problems again, but then also reach out if you have questions.